Alright, so this another question is similar to the last one. It's actually the same as the last one, except now the input is shifted. Sorry. Oops. How do I? Okay. The input is now shifted to the right. To the left by 2. Sorry, to the left. So how do we go about doing that? That's the way we do that is we find the Fourier series of x of t, right? We should have done that here, but for this question we actually don't need the x of t. But for this one we do, right? So how do we find the Fourier series of x of t? Note that we were given the values for k and the Fourier series coefficients. So recall that the formula for Fourier series is equal to x of t equal to the sum from k equals to negative infinity to infinity of ak multiplied by e to the j k omega 0 t, right? So we already know that what the values of k are from the previous question, right? So this has to be equal to, for k equals to 0, what is a of 0? 1, okay? Again multiplied by e to the j 0. So this is just 0. Oops. Why does it keep on changing the color? Multiplied by 0, right? So e to the 0 is just 1. So this is just 1. Okay, so for k equals to 1, what do we have? So a1 is equal to 2 multiplied by e to the 1 multiplied by j omega 0 t. So we already found that the fundamental frequency is pi over 2, right? So we just directly substitute here, pi t over 2. For k equals to negative 1, same thing, a of negative 1 is 2 as well, so e to the negative j pi t over 2. And so for k equals to 3, what do we have? 4j multiplied by e to the power of 3 pi j t over 2. And so for negative 3, it's 4j as well, because yeah, they equal to each other. 4j multiplied by e to the negative 3 pi j t over 2. So this is our Fourier series. So all we have to do now is just substitute t equal t minus 2. We just do the substitution. So x of t minus 2 is equal to 1 plus 2e j pi. So this is t minus 2 over 2. Actually, let's just factorize out the 2 plus e to the minus j pi t minus 2 over 2 plus 4j, okay, multiplied by e to the 3 pi j t minus 2 over 2 plus e to the minus 3 pi j t minus 2 over 2. There's barely enough space left. Let's just drag this out. Drag this out to the right a bit. Okay. So let's just expand this out. So this is equal to 1 plus 2. Okay. So this is e to the j pi t over 2 minus, that's just 2 over 2, right? That's minus 1. So multiply by j pi, we get j pi plus e to the minus j pi t over 2. Again, this is minus 1 multiplied by minus j pi, so this is plus j pi. Okay, for this one, 4j multiplied by e to the 3 pi j t over 2 minus 1, because minus 2 over 2 multiplied by minus 1 by multiplied with 3 pi j, so 3 pi j plus, same thing here, minus 3 pi j t over 2. So this is plus 3 pi j plus 3 pi j. Okay, so what do we have here? We have 1 plus 2 e to the j pi t over 2 multiplied by e to the minus j pi. So here j pi t over 2 multiplied with e to the j pi. Again here, plus 4j, this is e to the power of 3 pi j t over 2 multiplied with e to the minus 3 pi j. Here we have plus e to the minus 3 pi j t over 2 multiplied with e to the 3 pi j. Okay, so this is where Euler's formula comes into play. So recall that Euler's formula is equal to e to the I theta is equal to sine of cosine of theta plus I sine theta. So e to the, this is supposed to be j because we're in electrical engineering, ej, so pi cosine of pi plus j sine of pi. So what do we have here? Cosine of 180 is -1, so plus j sine of pi is 0. Okay, so this is just equal to -1, right? So because it's equal to -1, we can easily see what the other values are. For example here, so this is e to the minus j pi, so that's just equal to e to the j pi to the power of -1. So this is -1 to the power of -1, which is just -1. Okay, so this should be equal to 1 plus 2, what's that, -1, right? So minus e to the j pi t over 2. What else? Plus, so this is e j pi here, okay, that's equal to -1, so that's minus e to the j pi, minus j pi t over 2, so plus 4j. Okay, here we have to the power of -3, so e to the pi j minus 3. What is this equal to? This is just equal to 1 over -1 cubed, which is still -1, right? This is also the same thing because it's -1, right, to the power of 3, which is still -1. So all of them are -1. So e, okay, so minus e to the power of 3 pi jt over 2 minus e to the power of -3 pi jt over 2. So this is our y of t. Sorry, that's not y of t. This is x of t. We're just getting started. Alright, so let's just analyze this real quick. So what are the values of k here? Right, so the values of k here, this is k equals to 0, this was k equals to 1, and this is k open -1, this was k equal to 3, this was k equals to -3. This follows from right over here, this first Fourier series. So the values of k doesn't change because we're only changing the value of t. Okay, so what we have here is, well, basically the Fourier series shifted. What we need to find now is a of k, right? What are the a of k? So a of 0, okay, is equal to 1. Can you see that? Because this is just equal to 1. We're looking for the I guess you could say magnitude, right? The constant in front of the sinusoid. So about here, this is -2. A of 1 is equal to -2 because it's -1 multiplied by 2, so it's -2. How about a of -1? Same thing, -1 times 2, -2. How about a equal to 3? -4j, right? And also a of -3 is also -4j. Okay, so we just plug this into the formula right here, into this formula. Let's bring this down. Okay, let's copy that. Oops, paste it right here. Okay, this is the formula that we're going to use. Again, we have to look at the jk omega to see if we end up with, you know, if big H is equal to 1 or 0 or not. Okay, so k of 0, we already did this in the previous question, so let's just calculate it beforehand. So a of j k omega k pi over 2, because omega 0 is pi over 2. We already calculated that. Pi over 2. Let's do this real quick. When k is 0, 1, minus 1, 3, minus 3. Okay, when omega is 0, so keep in mind what this means. Omega is equal to k omega 0, which is equal to k pi over 2. So when k is 0, it's just 0, right? Again, look at this. Let me just copy that one. Okay. When k is equal to 0, then omega is also 0, right? And that's less than pi. So this is 1. Okay, when k is equal to 1, we have omega equals to pi over 2, right? So pi over 2 is less than pi. So this is 1 also. How about negative 1? Keep in mind, we don't care whether k is negative or not in this case, because there's a modulus here. So this is also 1. So how about 3? So when k is 3, omega is 3 pi over 2. That's 1.5 pi. It's obviously more than pi. So this is 0. This is also 0. So now we only look for when the terms when k is equal to 0, 1, and negative 1. So our output should be y of t is equal to, where is a of 0? So that's 1. Again, this is e to the j0 blah blah blah. So this is 0. So this entire thing is just 1. So a of 1 on the other hand is minus 2 multiplied by e to the j 1. So this is j pi over 2t. When k is equal to negative 1, this is minus 2 as well, to the e to the power of minus j pi over 2t. So that's it.